In this video, we will go through some of the built-in features that FiberPlanet provides to analyze the results of your design once it's finished. First of all, FiberPlanet will automatically create a bill of materials after each calculation. You'll notice that the Excel file has several tabs. In the first tab, we get a general overview of the design costs. One section contains some information about the processed area. There is another section with the general results of this design, and we provide a cost breakdown which is split up per layer of the network topology. It also contains a pie chart, so you can quickly identify the most expensive parts of the network. In the next tab, we have an in-depth overview of all of these costs per layer. For example, there is a section related to public trenching costs. In this section, you can find the different types of trenching that have been used. For each of these entries, you'll see the unit costs that were entered in the rules of material. The output also contains the calculated network costs. In this case, the volume indicates how many meters of aerial crossing have been used. And we can see the total cost that's associated with this volume. The next section contains the equipment costs related with the drop layer. In this case, the volume refers to the number of times that each equipment type has been placed. The same holds true for any of the following layers. Each section will report the amount of cables, ducts, and equipment used in that layer. Notice that we also make the distinction between homes passed and homes activated. Homes passed indicates that those costs will occur regardless of the adoption rate, whereas those costs marked as homes activated should only be counted if the customer actually decides to connect to the network. The next section is a price change tab. Over here, you can play around with some of the equipment costs. We could increase the cost of our aerial connections. Let's make them cost €15 instead of 15 cents. We can immediately see how this would impact our total design costs. Note, however, that this is just a general indication of how the costs will be distributed. If you want to have an accurate result, you would have to rerun your calculation, because the optimizations and the selected cable routes might be different if the unit costs change. We also have a bill of material per distribution point. In this tab, the costs are split up for each of the distribution points. You can identify them by their aggregation ID, which also is an attribute of the distribution point in the output shape files. This concludes the introduction to our bill of materials. Another great feature to check the results of your design is the built-in integration with Google Earth. To access this feature, just press the Google Earth icon. Your mouse cursor will change. You can now click anywhere on the canvas. For instance, let's check the central office location. This will automatically open up Google Earth, and you will be taken to the location where you clicked. You'll see a view of your design with all of the cables and relevant point locations. You can zoom in on this area. Notice that the location where we click in QGIS is also marked with an arrow place mark. We can now scroll through this entire area. This can be useful to inspect if our distribution point location is feasible in a real environment. We can even switch into Google Street View. This allows you to inspect how the cables might run in the actual environment. Note, however, that an actual field survey will still be required to make up-to-date decisions. Google Earth, however, already provides some assistance with making informed decisions. With this, we conclude the overview of some of the features for inspecting your design.